Morning, miss.
Sorry. Hello, can you hear me?
Yes, we can hear you.
Okay, great. So I will start, and for the people who are late, they should come early next time. I will tell them. Anyways, I'll share my screen. Can you see my screen?
Yes.
Okay. So my name is Engineer Hala Shihada. I will be teaching electronics devices and systems, EE312 for this lab, for this course. Regarding lab grading, it's 15% out of the course degree. Final lab exam will carry 10%, and the lab reports will carry 5%. There will be grade on participation, meaning you have to share your screen and show me your work. Maybe it's around 4 points each lab report will carry 4 points for participation. If you have an error or mistake in the circuit, that's okay. I can help you fix that error, but you have to show me that you are working to get the participation grade. Rules of the lab. Never be shy. Ask questions at any time and in anywhere. During the lab session, you can interrupt me at any time, or you can send me an email and we can set a Zoom meeting, or you can pass by my office in the office hours. I have posted my office hours in Moodle. So please don't be shy. I want you to be like question machine. Second rule is do not copy reports. I do not want to see any copied report. Any copied report will receive immediately 0, and I will not tolerate copied report. If you do not know how to write a report, or you have never written a report before in your whole life, that's okay. I can help you at any time and in anywhere. The third rule is do not compare yourself with others. Focus on yourself and compete with yourself. Each person is unique in his own way, and you should compare yourself today with yourself yesterday and work on your improving yourself. The lab report submission should be submitted within 3 days. So today is Monday. The lab report should be submitted on Thursday. The deadline will be Thursday. I will not accept any late submission. Any late submission will receive 0. And I will not accept any submission through email. You have to submit the report in Moodle, on Moodle. Regarding the software that we will be using, it will be Multisim offline. I do not know how to use the online version, so I cannot help you guys in doing online version. But if you have a MacBook, please install the Windows and install the offline version of Multisim on your laptop, please. I will read how to install Multisim PDF file that's possible in Moodle to teach you guys how to install the Multisim. So let's go to Moodle. You can see my screen?
Yes.
Okay, great. Okay, this is the PDF file. First, you will click on this link, and then you will go to sign up. You will create your username. Let's say Hala. My first name and last name. Role, select student as a role. Company, no, school. You should select KCST. Doha Road, Al Jahra. Email address, please use your KCST email address. I will write my email address. Anyways, and create the account, and then you will receive an email in your mail to confirm your account. Please click on that link, and then you have to open this second link, how to download Multisim. The included edition is education, and click on download, and then this page will appear to you. Please select on I accept the above license agreement and select next, and then next. You will see these pages appearing to you. And then on the license page, please write the license that I have sent to you guys on Moodle, and then click on activate. And then next, and then Multisim will be installed on your PC. This is how to install the offline version of Multisim. Now, for the lab today, I will do the pre-lab with you guys only for today. Starting from the next lab, you have to do pre-lab before the lab starts. At the beginning of every lab session, I will randomly call names, and these people have to show me their pre-lab work. So please do your pre-lab before the lab. Don't do it after the lab, because I will call your name randomly. Okay, the pre-lab for today is to analyze the input characteristics of BGT. The input characteristic of the BGT is drawn with the various value of BBE based to emitter voltage over I base at a constant value of BCE, collector to emitter voltage. So we will draw this circuit in Multisim, and we then have to fill this table. I will teach you guys how to do that. And then we have to plot the curve of BBE versus IB for value of BCE to be 14 volts. I will teach you how to do that. So first of all, let's go to Multisim and draw this circuit. So first we need 2 resistors. So place component, go to basic, resistor, select 1K, and then we need 200 ohm. So write 200. And then we need 2 voltage DC voltage source. So we'll click on place a source and go to power sources and click on DC power. We need 2. And then we need a transistor. The transistor number is 2N3904. So we'll go to place a component, go on all groups, and write the name of the transistor, 2N3904. Okay, then we will connect the circuit. Connect this to the collector. And then we need a ground. So we go to place a source, go on power sources and choose ground. Okay. This is VBE. Go to label and name it VBE. And then go to this one and name it VCE. 12 volts. Okay. And then we'll go to simulate, analysis and simulations, DC sweep. For the first source, it will be VBE. The start value is 0.1. The stop value is 1.5 volts. And the increment is 0.1. For the second source, it will be VCE. And the start value is 2. And the stop value 14. And the increment to be 4. This is all given in the manual of the lab manual of experiment number 1. It's all given by the doctor. He wrote it. Okay, then we'll go to output and we will click on IQ1B, meaning that's transistor number 1 base current, and we will click on add, and then we'll do save. And then we will run the simulation. So we will get these curves. Here we have in this table, we need to calculate the I base for different values of VBE at fixed VCE to be 2 volt. So if we go to multisim, here we have 4 curves. The first curve is for VCE equals 2 volt, and the second for 6 volt, and so on. So we need for 2 volts. So I will remove these curves. Now we have in the x-axis VBE, and on the y-axis the current I base. To find the values of I base at different values of VBE, I will click on cursor. Here we have 2 cursors. X1 means cursor number 1, x-axis, and in this case the x-axis is the VBE, and the y-axis Y1 of cursor number 1 is the current. So let's say we want to find the I base at VBE to be 1.5 volts. So we will go to the cursor number 1 and we will move it to 1.5 volt, the x-axis to be 1.5 volt. Wait a second, 1.5. The maximum 1.5. Okay. Here, it's 762 microampere. So you have to write here 762 microampere, and so on. Do the same for all values of VBE. Do the same procedure. And then here, this is for VCE equals 2 volts. You will do the same for VCE equals 6 volts. So you will remove this one and click on VCE equals 6 volts. You will do the same procedure. You will move the cursor for different value of VBE, find the value of IB, and so on. This is for VCE equals 6 volt and VCE equals 10 volt. Here he says that he wants the curve, plot the transistor response curves of VBE base and I base for a value VCE equals 14 volts, meaning that we will click on the VCE equals 14 volt curve and we will remove this curve. And please take a screenshot using snippet tool and add it to your lab reports. Okay? Any questions so far?
Can you go back to IB and do it just one more time?
Okay. So what do you شو اللي مو فاهمه بالضبط؟
كيف نحسب الاي بي؟
Okay. First of all هحكي لك انه VCE 2 فولت. So first of all رح نعمل كليك على الكيرف اللي فيه VCE 2 فولت. This curve, red curve. Okay. We will remove الكيرف تبع VCE equals 14 volt. تمام؟ Until now. Then for different values of VBE احسب ال IB. أنا يعني let's say we want to calculate the IB for VBE equals 1.5 volts. So we will take the cursor. Here we have a cursor, two cursors. The x-axis is VBE and the y-axis is the current I base. And here we have x1, y1. x1 is the VBE and y1 is the I base. So we will move the cursor until we reach x1 to be 1.5 volts. It will be up. Okay, here x1 is 1.5 volt, which is in this case, x1 is VBE. And if you go to the schedule, okay, VBE is 1.5 volts. So I base is basically the y-axis, the current. It's written here, current in the y-axis. It's y1. The value of I base is it's y1 and it's 762 microampere. Okay, or لسه عادي
لا
اسال.
اوكي.
خلاص تمام؟
لا كثير. يس تمام.
اكيد؟
يس
اوكي
اكيد.
تمام. هلا هذا بالنسبه للبري لاب. رح تعمل نفس الشيء ل VCE equals 6 فولت و VCE equals 10 فولت. يعني رح تعمل كليك على VCE equals 6 فولت. You will remove the VCE equals 2 volt. رح تعمل the same procedure. رح تحرك الكيرسر على different values of VBE وتطلع value of I base اللي هو y axis in this case. For VCE equals 6 volt and VCE equals 10 volt. ورح تعبي الجدول. ونفس ما قلت لك إذا بدك تطلع الكيرف تبع ال VBE versus I base for value of VCE equals 14 volt, just go to multisim and click on VCE equals 14 volt. This curve, the blue one, or just take a screenshot and add it to your lab reports. Okay?
Okay.
Okay. هلا الاكسبيرمنت في عنا two parts. The first part is to analyze the output characteristic of BGT. The output characteristic of the BGT is drawn between the various values of BCE based to emitter voltage over IC. IC here collector current. It's not base, collector current at a constant value of I base. This circuit رح نرسمها بالمالتيسم وبعدين رح نعبي هاي الجدول ورح أعلمكم كيف نعبي الجدول. Okay, first of all خلينا نرسم السيركت. We remove this one. ونروح على place source. Let's wait a second. في حد بيعرف وين نطلع الكرنت سورس؟ wait. هيك اوكي. DC okay. You go to signal current sources from place a source. Okay, first of all you go to place a source and you go to signal current sources and then you click on DC current and you add it to the circuit. And then you connect the base to this one. وقيمته 1 ampere. Okay, and then هنروح على simulate, analysis and simulation, DC sweep for first source BCE, start value to be 0, stop value to be 2, increment to be 0.4. Here for the second source, we will put I1. For start value 10 e to minus 6, stop value to be 20 e to minus 6, and the increment to be 2 e to minus 6. E to minus 6 means microampere. And then we go to the output, and we'll click on, we remove this one, and we will click on IQ1 IC, the collector current of transistor 1, and we will add it, and then we'll do save, and then we'll do run. Oh my god, I need to do the circuit. No, I actually have the circuit, I did it before. So let's go to electronics, first part, second part. Okay. So we get this curve. So we go to the schedule. احكي لك find IC اللي هو corrector current for different values of I base and for different values of VCE. So first we will fix, راح نثبت ال I base. Let's say إن ال I base 10 microampere وعشان نطلع ال IC for this case. So I base equals 10 microampere. This will be the red curve, and we will unclick these curves. And then for VCE, for different values of VCE. So we'll take the cursor. We'll take the cursor from here. Let's take cursor number 1. So in the x-axis, we have VCE, and in the y-axis, we have IC, the collector current in the y-axis. So let's say we want to calculate the IC for VCE to be 2 volts. So we'll move the cursor until the x-axis reaches 2 volts. Here, 2 volts. The x1 is 2 volts, as you can see over here. And the y-axis, which is IC in this case, collector current, is 1.401 milliampere. So راح تروحوا على الجدول وتكتبوا هون 1.4031 milliampere. راح تعملوا the same procedure for different value of VCE. يعني next case will be for VCE equals 1.6. راح تحركوا الكيرسر ل x axis تكون 1.6 وراح تشوفوا قيمة ال y axis. ال y axis in this case 1.3940 milliampere. راح تكتبوا هون عند 1.6 الرقم الكرنت اللي طلعتوه. This is for IB equals 10 microampere. For IB equals 12 microampere راح تروحوا على المالتيسم، راح تعملوا unclick للريد كيرف، راح تعملوا كليك للجرين كيرف لأنه الجرين كيرف هو اللي عنده الكرنت تبع ال I base 12 microampere. As you can read over here, this is 1.2 e to minus 0.5, which is equivalent to 12 microampere. Okay. فرح تروحوا تطلعوا قيمة ال current IC for different value of VCE. Same procedure. نفس الشيء بالنسبة ل I base equals 14 microampere. ونفس الشيء بالنسبة ل I base equals 16 microampere. هلا هون طالب إنه طلع ال curve for I base equals 18 microampere and I base equals and I base equals 20 microampere. So رح تروحوا هون رح تعملوا on click على هذا. هون 1.8 E2 minus 0.5 it's equivalent to 18 microampere. So we'll click on it. 1.8 E2 minus 0.5 it's equivalent to 20 microampere. So you will click on it. ورح تعمل سكرين شوت ورح تحطوه بالريبورت وبس. هذا بالنسبة للفيرست بارت. The second part, any questions till now? Hello, any questions?
Yeah, clear.
Are you sure?
Yes.
Yes,
Okay.
clear.
Okay. هلا second part تبع experiment is about analyzing the output versus input characteristic of BGT. It's drawn between the VBE base to emitter voltage and VCE collector to emitter voltage. So we will draw the circuit on multisim. We'll remove this one. We will add 1K. Base component, basic, 1K. Okay, and then we'll do simulate, analysis and simulation. راح نحط source number 1 to be VBE 0 and then 2.2 increment to be 0.2 and then the output to be V3 and then add. So we do run. Okay, this is the curve. هون بده هو for different values of VBE طلع لي قيمة ال VCE. فإحنا عندنا بالX axis VCE وبالY axis VBE. So عندك الكيرسر راح تحرك ال VBE. Let's say we want to calculate the VCE بالنسبة ل VBE equals 2 volt. فراح نحرك الكيرسر عند الY axis to be الY axis لازم يكون 2 volt. لازم يكون 2 volt لأن Y axis it represents VBE. فبدنا نحرك الكيرسر عند الY axis يكون 2 volt. Wait second. 2 volt راح نحركه تحت 2 volt تقريبا هون. فالX axis is 1.16 volt. VCE 1.16 volt as you can see over here. X axis هو VCE والY axis هو VBE. فالVBE is 2 volt. VCE is 1.16. فراح تروحوا على الجدول وتحطوا 1.16 over here. وراح تعمل نفس الشيء ل VBE equals 1.8 and VBE 1.6. Same procedure. Let's want to calculate the VCE for VBE equals 1.8. راح نحرك الكيرسر Y axis يصير 1.8 over here. Okay. هي Y axis is 1.8 وال X axis is 1.17. فراح تروحوا وتحطوا 1.17 volts. Here بحكي لك plot the transistor response curve for VC equals 10 volts. So this, you will just do screenshots for this curve and add it to your lab reports. Oh yes, that's it for today. ما في other parts. But if you guys are doing the experiment right now with me, if you have any issues, I can help you guys right now. If you want to share your screen, I'm ready to help. في حد عم بيسوي السيركت حاليا أو سواها؟
سويت 3 تقريبا.
Sorry.
سويت ال 3 circuits.
Okay, عندك issues?
لا.
Are you sure?
طبيعي. Do you want me to share my screen for the second one? The
Sorry?
first one?
The first one? مالها? What's wrong with it?
No, nothing wrong. I was just, if you want to confirm something.
Okay. So confirm what?
إنه كل شيء صح. If you want.
Yeah, you want to share your screen يعني?
Yeah, just to
Okay.
check it.
Yeah, okay. I will stop sharing. Oh, you can share your screen. Okay. تمام. It's good.
قيم هيك صح تقريبا طلع معك نفس الشيء على 1.5.
Let me check. This is for
The first experiment.
okay. Let me check. Wait a second. No. بس شوي ممكن تحرك شوي الماوس؟ شكرا. Yes, it's correct.
السكرين شوت بس لاخر واحده اللي هي لا VCE 14 صح؟
The VCE 14 exactly.
Okay. Thank you.
Thank you. أني في حد ثاني بده يعمل share screen؟ Guys, hello. Starting from the next lab, there will be grade on participation, meaning that I will call people by name and they have to share their screen to me. And I will see if they are working or not, starting from next lab. No response. Okay, I think that's it for today. But as I said, starting from next lab, there will be grade on participation. So I will ask each one of you to share their screen. And you are only 20 students in this section. So I think I can handle 20 students sharing their screen by that with 2 hours time slots. Okay. Thank you for your participation and see you next week.
Thank you.
Thank you, Doctor. Thank you, sorry, Abdullah.
Yeah, thank you.